Welcome, hackers, to the Hackfest. And well, my name is Lluis Gifre. I will be chairing the session together with Ricard, Georgios, and Panayotis, as Sylvia mentioned. As I said, if you hadn't downloaded the virtual machine, or you don't have the copy, or you have any trouble, let me know. We have here some the USB drives. I'm asking again for the people that is arriving right now. During this session, we will we will explain like short course. We will be using a virtual machine that is the one that I was mentioning beforehand. In this, this is the link to download the virtual machine. Also, you have another copy in a shared repository. As an important, yes, please. Important point, the user and password for the virtual machine, in case you need it for running any command, it's user TFS, password TFS 123, everything in lowercase. After that, let me ask that the different commands that we will be using for this Hackfest are collected in a text file. It's for your convenience and to prevent problems and trouble with symbols and special characters and so on. So feel free to use this file for copy pasting the commands. And also, well, you have the access here to the different to the file. It's in the folder Hackfest within the working space that we have, and it's this file in the code repository. And as a last step, we will be using, as Sylvia mentioned it, the development version of the TeraFlowSDN controller. It's a work in progress, so what I will propose you to do whenever you start your virtual machines is to do a git pull to get the last version of the changes, because we were pushing some last-minute changes. I mean, it's just polishing some files and some tutorials for your convenience. Feel free to do that. Also, we will be using a Python environment for running some of the commands. In principle, this environment should have all the required libraries and Python packages pre-installed and pre-configured. So be sure that you are using the appropriate file. Sorry, the appropriate virtual environment. Besides that, quickly going through the agenda. First of all, we got the welcome and logistics with Sylvia. That's done. After this brief introduction I'm doing, I will pass the token to Ricard Vilalta. It's our leader group chair in TeraFlowSDN controller. He will bring motivation, and he will be presenting some of the sections in this Hackfest together with me. First, we will go through, before lunch, we will have some sessions involving southbound interface protocols and so on, mainly about Yang data models, then netconf protocol, and after that, we will go through the ONF transport API. These three sections are important building blocks because it's the basis for understanding how TeraFlowSDN controller works, so it's important. After that, we will have the group picture that Sylvia was mentioning, and the lunch break. After the lunch break, we will start playing with the TeraFlowSDN controller, first with an introduction. Then we will go through the deployment of the TeraFlowSDN controller. We will be onboarding some network devices and playing with programmability of layer 3 routers. After that, we will have an afternoon break, and the last block will be about some monitoring with gRPC, and finally, Georgios and Panayotis will bring an introduction on P4 using the TeraFlowSDN controller. And after that, we will have the conclusion session where we will circulate and we'll ask for your feedback, your ideas, maybe ways we can improve, and so on. So that's the agenda. Well, this is the Hackfest team. Silvia was presenting this very same slide, but in this one, we have also Panayotis, so you know who is him. And after that, I will pass the token to Ricard Vilalta, our leadership group chair. So, no? Okay, perfect.
So I'm doing the boring stuff. So let's talk a little bit why we have reached here, we are here, and what's the motivation behind this Hackfest. Also, what's the motivation behind TeraFlow. The idea is to go from SDN, from traditional architectures to SDN architectures. That's a motivation for using SDN. Oh, you need any more? Okay, maybe it's better now. So I will be motivating while you are downloading the stuff, and so it's easier for you then to jump in. But let's explain a little bit what's the difference between the traditional architectures in SDN and what is not. So we think that the difference is not in the standardized interface management interfaces. We have this since the 80s with SNMP protocol and MIB. We have a standardized architecture that's also available since quite a while long. It's not about open interfaces. It's not about use cases. It's about changing the way of thinking, introducing programmability to the network, introducing open source based developments, and simplifying our networks through abstraction. So this is the reason why we are here, why we are bringing SDN to the transport networks. So we are applying these basic three principles of SDN, programmability, openness, integration, to the different transport networks. And which are the different benefits? It's clear. So we are introducing innovation. Transport networks are typically slower than clouds that you might be more used to, or other network locations, or even the edge. So they are slower. So we are bringing there with SDN more innovation, with openness. We are simplifying the architecture, so we are having a multi-layer architecture. But we are integrating this to end-to-end connectivity services, and then we have also some financial benefits. So we are fastly reducing the OPEX through the provisioning of more efficient service setups. So that's the motivation for introducing SDN in the transport network. And one of the keys to success, we think that one of the keys is to break silos. So our metric of success is to allow multi-vendor interoperability to have industry adoption. So it's clear that we want to break the silos, we want to have this industry adoption, and that's the reason of TeraFlowSDN. In fact, this is our Trojan horse to obtain these different metrics of success. I think that's the most important thing to keep in mind. And just a couple of warnings. So we want to move. We need to check to be sure that we are not moving from silos of hardware to silos of software, and we need to avoid also new silos for management. So it's very important, these key metrics, and keep this always in mind while we are presenting this project. And what I will show you during today on the most tutorial-like part, not on the Hackfest, is some kind of results that we obtained in a paper where we consider all the multiple different netconf protocols, the different RESTconf protocols, and so on. And I will be comparing them during the whole day. So when we show you some data, you might be interested in knowing, for example, which is the overhead of my protocol, which is the latency of my protocol, That's some data that you will find today. It is you can read it thoroughly in this paper, but you will learn during today a lot of protocols, a lot of interfaces, and you might be interested in to know which is the specifics of each of these protocols. And I think that we have summarized it very well using two different network topologies. Where is it? Oh, they are not here. Okay, they failed. Okay, so we had two previous network topologies. One is, well, you will read in the paper, and we have measured there the latency and the overhead in bytes of the protocol. So it's very important when you compare, for example, how and why do I use netconf, or why do I need to use resconf, or why makes it sense to use gRPC. This paper will help you and the information that we will provide you. So from theory to practice, we will be playing with TeraFlowSDN today. So this is the architecture for TeraFlowSDN. We will later enter into the details. Just a short glimpse so you can observe that we are tackling different network interfaces that we will be having a tutorial this morning. And then we will play a little bit with the TeraFlow that it is deployed in the virtual machine. But first of all, we need to learn all the different steps step by step. So first I will talk about Yang data modeling. Then we will talk about netconf configuration protocol. We will go to resconf. Then later we will talk about transport API. And then we will see TeraFlow. And at the end of the day, we will see the P4 protocol. So there's plenty of stuff during this Hackfest, and I think that you will welcome it. So let's jump to the experimental evaluation. We need to have fun during today with network automation, and I think that we will have it, and that's what the outcomes that you will take. So let's start with the Yang data models. So this is very focused on optical transport networks, but it can be also applied to IP routers, for example, using the OpenConfig protocol. So we need to model networks, and we need to understand that a network can also be part of can be managed without a control plane. That's something that you can do by simply switching the different fibers, the different ports, and that's from the perspective of the operator, that's very cost inefficient. So we need to introduce the control plane in order to provide more flexibility, to reduce the OPEX, and to ease the introduction of network services. That's why we need to be able to model these features with some kind of unified information language. So that's when the concepts of information model and data model appear. We can define that for a device, an information model, it describes the different device capabilities in terms of operations, parameters, and different high-level abstractions. But there is no specific details on how that can be encoded. The data model goes one step further and determines the structure, the syntax, and the semantics of the data that is externally visible. It's me? Oh. No. Okay, so that's the different classical definitions for information model and data model. And then we see that we need to have some language for that. So we need to have an architecture for remote configuration and control. We need to have also an associated transport protocol, and we need to agree on the standards. So we have, per each kind of device, we have a standard data model. Okay, so let's jump to the Yang model. So Yang is the most known data modeling language. Okay, you might have seen others before. I was talking about the MIB, and I was also before that. All people like me, we have seen ASN.1, for example, at Etsy. So there are many different Yang data modeling. Yang is just the last one, the newbie on the block. It has been there for a long time, but it's not the first one. So we have seen a lot of that stuff. in the market, we think that Yang at least is stable right now. It allows us to do a lot of things. You are using it in OSM. It is being widely used in transport networks, and that's why we are talking about this as introduction. So that the Yang language, it allows to include headers, import Yang files, so it can be recursively used. It allows to include statements, type definitions, configurations, and the operational data declarations, as well as the different actions and notifications. So it's a complete, fully featured language that it's expressive enough to structure the data into different trees, which we call data stores. That's an important concept in Yang. By the means of encapsulation of containers and lists, and you are providing a hierarchy that's very, and you can define constrained data types. We can also condition the presence of a specific data to support these optional features. You can also allow the refinement of the models, and finally define configuration or state data. Yang has been the modeling language for multiple network control and management aspects, covering devices, network services, and even pre-existing protocols. So we are seeing a Yang model of an old protocol, so that's very common. And some examples, so for example, an SDN controller maybe export the underlying optical topology in a format that's not ambiguous and using this Yang schema, or even a high-level service can be described using the Yang data model so that you can understand what the SDN controller is bringing to you. So that's let's start with the first things on the Yang example. So I would like you to practice a little bit on how to construct a Yang data model. So let's first do an example, and then you will need to replicate it with another model. So right now we want to model a network topology of a network. So a network shall consist of different nodes and links. And each node shall consist of node ID and different number of ports. A port shall consist of one or more one port ID and the type of the port. And a link consists of different of the link ID, a reference to a source node, to a target node, to the source port, and the target port. So you have this kind of a small model. If we take a look at how this looks like, so you have this in the virtual machine installed, but let me go through it in the slide. So we can observe a namespace here for the topology. We can observe a revision, so we have a date. We can have multiple revisions of this file, so we can update the information model. We have the root. In here we have the root name for topology, so we create a container. So that's the root that uses topology. Topology is like a patch of code that describes a topology, including a list of nodes and a list of links. So these are the key topics, the key keywords: container, grouping, list. Then we can observe here that a grouping of a link includes all this information. Let me just go first to the grouping of a node. So a node includes a leaf of node ID and includes a list of ports. Each of them is described using the port, the grouping port. So we have the leaves. Remember that we are on a tree structure. So we have containers, list, and finally we can have the leaves. And that's what you obtain. So we have here a port. Then you can also describe some types, specific type defs. For example, for the layer protocol name, so the port can be either electrical or optical, for example. And that's what you get. So this is the very basic example. That's a very basic example for all the different kind of a Yang data model of a topology. So we want to validate this Yang model using Yang. How many of you have used Yang before? So just to get a feeling on the to be fast so. Okay, I'm sorry guys because you will need to wait a little bit more for the fun. But if you just check on the room side, then there are like 10 people that are not knowing about Yang. So let's be fair with them. It's very important that they get these concepts because they will need them during the tutorial, and if they want to play with TeraFlow, you need this information. So you can validate your Yang data model using Pyang. You can have the tree. That's how a tree looks like. That's the same code I have shown you before, but this is in a human readable way. That's the best way to read it. You can also export it to XML and so on. So that's what you get. That you can also generate a UML diagram using these two commands. So it's very simple and easy. You have here an example. You need a Java binary that's called Plantum, Plant UML, and that's very useful for generating this kind of graphics. So you can also generate code in a very simple way using PyangBind. And that's something that my guess is that OSM is using, and also we have used it for TeraFlow. So that's a source code generator that eases your life a lot, and it provides Python bindings for the different YANG files. So it also allows to generate the different data model as a class, and to export the class, to import the class, and so on. So it eases your life a lot. So this is the first example for the tutorial, how to create the topology. So if you remember before, we had that with the YANG file. We can generate the Pyang file with the different bindings. I don't know where the VM is, so that we can. I'm a terminal guy. So we go to our Hackfest folder for Yang, and here we have the example that we were looking for. So you can validate if you do a Yang Pyang tree. Topology.yang. So you have here the tree. If you do a Pyang bind, you can generate automatically the binding. So if you check the binding, I have previously generated. So this is a complete class of the topology. And now we have an example of how to use this class. So how to create an instance of topology that has two nodes and a single link. So you have in the example, if you take a look, you have in the example the topology that we want to recreate. And it shall include two different nodes, a single link. How do we do that from the perspective of the code? You have it available in the topology.py. So if you check topology.py, you will see that's the same code that's on the slide. And if we take a look at how it looks like, okay, I'm importing the library. So I'm importing topology. I can create a class topology. Inside the topology, I add a node with this node ID. Inside node, I can add ports in this way. So this is how we are handling the array. And we can create the link on the topology, and then we include the different information for each part of the link. Pretty simple. We can then print it in XML, or we can even print it in JSON. So let's take a look at it. How does it look like? So if we take a look at what it does look like, you can first see that I have printed the XML as it is there. So with one node and two nodes in topology and one link, and then in the JSON way. So we can also have this. These bindings allow us to create objects very easy, to import them, to export them in JSON or XML. So that's very useful. So that's the first thing I wanted to show you today. Okay, that's the XML, the JSON. So let's do some exercising. So I will leave you 5 minutes to work on the connection. So we want to model a connection database, let's say that data store that consists of each connection consists of a connection ID, open of the source node, the source port, destination node, and destination port, the bandwidth, and the layer protocol name. So we want to have a list of these connections, and we want to validate that with Pyang. We want to create Pyang bindings and to create an XML using these bindings. So that's the exercise I will leave you for now, and I give you 5 minutes. You should be even with less time. You should be able to fill it with examples, and if not, we have the solution in the VM, and we will run it just now. So you have 5 minutes. So let's see the solution. So very simple how this works. So we have a grouping that's a connection, and at the end you can see that we have a list connection, and that's the key connection ID, which this list has different connections. That's how this looks like. Each connection has these leaves and the different leaf ref. So that's how this looks like in UML. This is generated with Pyang bind. You have the solution available on the virtual machine. If you go to the Yang CD connection, you can have here, for example, the tree, the UML diagram, and also the bindings. And if we take a look at the connection.py, you will observe how we have generated the connection. So you observe that we are able to generate XML of an instance of connection and also a JSON. So we can export that. Okay, so now it's time to jump to the netconf protocol. We have now learned how data models work, but we need to have some primitive to view and manipulate this data. That's very important. So we need to provide a suitable encoding for this management of the information. And I always say that the transport protocols and the data models languages should be completely separated, but that's nothing that happens. So we have netconf very tied to Yang data models, and this protocol enables access to a device, and it provides a set of rules to manipulate, which can manipulate the access and modify the data store of the device. The device is the one which has the server, the netconf server, and we have a netconf client that's able to act on top of the device. So it's important to always understand the hierarchy. The netconf protocol is based on XML encoded RPC messages over a secure, typically SSH connection. So this is the different protocol stack that you find and how the different layers apply. You can observe here, for example, that how this netconf protocol can be used. You can establish a session over a secure transport. We have both entities saying a hello message. Then we have they announce the protocol, the different protocol capabilities, the supported data models, the server session identifier, and then you can start the fun by requesting different operations. Most significant netconf operations are listed here. So you can, I would say that the most significant ones are the get config, the edit config, copy config, log, unlock. These allow access, concurrent access to databases, so you can log the access if you are a client, make the modifications, and unlock the access. So we avoid concurrency in this way. So that's how a connection look like. We want, for example, to use this connection list that we have generated the data model before to be able to ask for connections, to create new requests for connections, and so that we can answer them. So this is very oriented to create connections, and that will be what we will do with our basic server. So we are providing an example of a basic server that reads on the port 8, typically on the port 830, handles one RPC. So it is able to read and parse the data file, topology XML, and it can provide it when config is requested. So we are serving as a capability the topology. Just be careful. For the virtual machine, we will be using the port 8300. So, Lluis, I think that now it's your turn to talk about the basic server. Yes. So, some hands-on experience.
So yeah, this basic netconf server, the idea is it's implemented in Python. I mean, it's using a standard library that it's provided in the PIP repository, in the PyPy repository. Sorry, you have the documentation available here in this link. And the idea of the server is that it makes use of other already provided libraries like Paramico and so on to expose the SSH interface that implements the netconf protocol. And the good point of this library is that it brings the logic of the server already done. So the only thing you need to implement is the particular functionality you need to, the particular logic you want to run whenever a specific command, like edit config or get config that Ricard was mentioning, it's received at the server. In here, what we will try to do is to read and parse the data in the topology XML file, and then provide this information by means of the get config command. Well, you have here the basic tutorial for netconf in case you want to elaborate a bit more on that. And well, this is the structure of the server. Let me put in full screen, so maybe it will be easier to read. The idea of in this server, as you see, we are first loading the topology binding. This is the file that was provided in the previous example about Yang. After that, we are, well, just initializing things. We are then loading the namespace for this topology.yang file into the netconf server namespace. And then we have different parts. The class for the server, we will elaborate a bit on that in a moment. And then the code to start it. The code to start, the thing is very simple, just instantiate my server. We provide the username and password that we want to use for this specific server, and the port where we want the server to be listening on. After that, we just wait till for the server to run, because it's running in a separate thread. And whenever we want to close, we just run the close method. That's it. For the implementation of my server, what we need to do is first, in the constructor, we are providing, as I say, the parameters for the initialization. Then we are loading, well, all the SSH stuff. That means the server key, username and password, and so on. And then we initialize the netconf SSH server. Here is where we are providing which is the class that implements the server methods that we want to be executed, and then also the authentication and the port. After that, we run this load file method. It's over here that is reading the topology. Then it's decoding this file by means of the TeraFlowSDN IETF XML decoder. And after that, we serialize it into XML. So in a way that we will get the information as we need to retrieve it. Well, then we are adding just the surrounding for the netconf data tag. And after that, we store this XML information into the node topology. That way, we get the server prepared. And we are providing just two simple methods in this basic server. One of them is about appending capabilities. That's to specify which are the capabilities that are supported by the netconf server. In particular, we are specifying that we support the XPath 1.0 and so on, and then that we have the capability for this topology model that we were working on in the previous exercise. Then we are providing here a very basic the simplistic implementation for the getConfig command. For that, we need to prepend RPC _, and that way this netconf server the netconf SSH server will know that whenever it gets the getConfig method, getConfig command, it needs to run this method. Okay, the simple thing that needs to be executed is just using one utility method that it's provided by this netconf library that filters the results. In this case, it's filtering the node topology, the one that has the topology preloaded, according to the RPC parameter that contains the filter that was specified and so on. So that's more or less the thing. So let's do the quick test in the virtual machine. Okay, let's jump to the virtual machine. I will use the VS Code. Okay, it's maybe too small. Let me zoom it a bit. So let's open the folder. Oops. In this, in the Hackfest folder, you have the netconf subfolder, and here we provide the different files that you might need. You can see here, for instance, the implementation of the server topology. It's the file that I was describing beforehand, so it's already described. Then you have the topology XML file. It's the one that we will be loading in the server. And we have here the topology binding file that was generated by means of pyang bind. Okay. We have also the other files that are needed. So let's now open here a terminal. So, well, you know, Control, Shift, and P opens this command line that is quite useful for VS Code. And here, if you write terminal, you can open a terminal. Be sure that you get this namespace, otherwise it will not work. If it's not working, let me know, because then, well, or you just need to run a command that it's pyenv activate and the name of the virtual environment that needs to be used. After that, okay, let's start the server. For that, we just need to, let me go first to the Hackfest folder. Okay, Hackfest netconf. So we are here, the right folder. So then, if we run Python, where is the file? Okay, so we have the server now that is up and running. You see, so it first dumps the topology and when it starts, so that way we can see what do we have. And then we have also a client topology file. This client topology file, it's a client that will use also the same library, the netconf library, to interrogate the netconf server. Okay, we provide here the parameters. It's the local host and the specific port that we are using, the username and the password. Then we instantiate the netconf SSH session in this case, not server. And with this session, then we can interrogate the capabilities of the server. We can get the information, and then here we are directly closing. So here it's very simple example. Let's try it. Oops, sorry. Let's try it. You can click this button here to open a new terminal. So you have the one with the server here. You have the other here for your client. Let's go to the Hackfest, netconf. We are here. Then if we run Python, client topology, we can see here that we got from the netconf server first the capabilities and then the content of the topology. Okay, so that way we can test the netconf server. Now let me jump back to the slide. Well, I was explaining more or less this the netconf client. This is the code I was briefly explaining. And what we will ask you to work on now, well, it's about extending the server and the client briefly. Before that, something I forgot to ask, it's that you can run, for instance, here Wireshark to see how are the messages that are exchanged. If you start Wireshark here and you click just start capture, oh sorry, I chosen the wrong port. If you choose here any and you start, you will get all the traffic that is exchanged here. So here let's try again to run the client just for you to see the packets that are exchanged, and you can see here the traffic. Okay, you see it's port 8300. It's not recognized as SSH. So here, if you want to see the SSH traffic being decoded, I recommend you to add here in analyze, decode as, and then you can specify here a new filter and say, okay, I want to filter TCP port, in particular the 8300 port, and I want to decode it as, we should be able to find here SSH, oops, sorry, SSH, okay, and now you can see the SSH messages that are exchanged between the client and the server. You can expand them and well, see the details that are not encrypted because for sure it's SSH, so that's part of the game to have data encrypted. But well, it could be useful from time to time to see this. So going back to the slides, I was presenting here the client and the server briefly. What I propose you to do now is an exercise of writing the edit config and, well, including the configuration.yang. And for that, well, we will bring you like maybe 10 minutes, 15 minutes. And you can try to extend the files you have in the virtual machine. You have the solution here, so don't worry. And the idea is that in the client, as I was showing, sorry, it's over here. You can add this edit config method to edit the topology, for instance, or whatever. So you can try to edit the topology, or you can add the connection, up to you. So, yeah, you can go ahead, and later we can see how it works. By the way, if there is any question at any point, feel free to interrupt me or You have in the Slack channel, in Slack you have a channel that is specific for this Hackfest. So feel free to drop questions there, or if needed, and we need to exchange some command, whatever, we can share it through the Slack or even through the pad. Remember that we have the pad where you can drop commands, questions, comments. Yes, please.
Okay, my apologies. I was still setting up my VM, getting it going. So I actually had to go into the network settings and manually change everything. Is that because of the fact that I've got a new MAC address? Is that to be expected?
Yeah.
Okay.
It's and it works, right?
It works now.
Okay.
I just wanted to confirm with everyone. You might need have to go into settings and explicitly follow the part in the
yes.
tutorial
you have
that
the
says
steps
about
here.
how to install it. So
otherwise, you can follow these steps in the Hackfest channel. I was uploading here some configuration notes about changing the USB controller,
yes,
for instance,
okay.
or you can change the network, the NAT network by the normal NAT. Up to you.
Okay,
Here,
perfect.
so you can follow this step, for instance, and it should bring the NAT connectivity up again. So, yeah. And if you have trouble, for sure, let me know.
Okay, perfect. Thank you.
You're welcome. Let's check the solution for that. You have here the code for this exercise. So very simple. First, we need to import the different libraries that we might need. That means JSON and request, NetworkX, and, well, the HTTP basic authentication. We have a section with the different constants that we might need, the IP address and port of the server, the identifier of the topology, and then the URL that we need to interrogate to get all the topology here. We have a method that we can use to retrieve the topology. It's just a get method, nothing strange. We decode the response as JSON. Here we are dumping, just for the sake of debugging. And then we need another method that is to draw the topology. Here we are creating a directed graph using NetworkX. And for each of the nodes that we have in the topology, we get the node edge point. Well, if the node has node edge points, then we are adding this node into the topology. And then for each of the links in the topology, we get the node edge points, in particular their node unique identifier, and we add the edge. That's it. Then we have two options. We can use the matplotlib method to create the PNG file, or the PyDot. Here you have the code for both of them. It's just a classical recipe for creating the plots from you have methods from NetworkX to draw for matplotlib, and if you want to use PyDot, then you have methods like to-PyDot to create the dot representation of the graph, and the right dot that takes a graph as parameter and creates the dot representation in text if you want. So you can get the two outcomes. Then running the thing is as simple as first retrieving the topology with the parameters and then drawing. So very simple. Let's try to run it on the virtual machine. So for that, you see here I have the TAPI application folder. It's inside TAPI folder, and you have the code. Okay, let's try it. So if we go to the TAPI, okay, I will, well, you have here the files, so I will delete just to demonstrate that they are created. Then here Python TAPI app, okay, and we got the two files regenerated. So we have here the topology. In this case, it's with PyDot, and if we check the OLS topology, you see that it added all the nodes into the topology and the unidirectional links. So that's it.